Let's take a look at this example. I have limit with x approaching to 0 with sine 7x over tangent 3x. Again, we're supposed to look at the denominator. Instead of x, we're supposed to write 0 in the denominator and check what value this trigonometric function is going to give me. Tangent of 0 is going to give me 0. We said we do not want to have zeros in the denominator. So we're supposed to do something with this problem. Because we have trigonometric functions, we are going to try to use this formula a lot. Okay, so how are we supposed to approach this problem? Simply write limit x is approaching to 0 and I have sine 7x. If I want to use this rule, I'm supposed to make sure that in the denominator I'm going to have also 7x. But the original problem doesn't have 7x in the denominator. That's why I'm going to compensate this 7x by 7x in the numerator. 7x and 7x will cancel out. That's why I'm going to get this expression equivalent to the original one. So let's say that we've finished at this moment with the sine. Now we're supposed to get to the tangent. So we can rewrite this as 1 over tangent 3x. You're supposed to keep in mind that tangent is nothing else just sine over cosine. So we can rewrite this as limit with x approaching to 0 and I have sine 7x over 7x times 7x over 1 times 1 over sine 3x over cosine 3x, because we said that tangent is equal sine over cosine. So tangent 3x is sine 3x over cosine 3x. What we're supposed to do next? Again, rewrite everything whatever you don't use. I have limit x is approaching to 0 and I have sine of 7x over 7x times 7x over 1. Remember, anytime we divide fractions, we're supposed to copy the first fraction down. In this case, we're going to have 1 over 1 and division change to the multiplication and flip the second fraction upside down. That's why I'm going to write this as a cosine 3x over sine 3x. Now, what we can do next? Again, let me copy down everything whatever we didn't use, just in order to make sure that you are going to understand everything step by step. So I have limit x is approaching to 0, sine 7x over 7x times 7x over 1 times, I'm going to write cosine 3x over 1 times, I'm going to write this time sine 3x, and because I have sine 3x and I want to use this formula in the numerator, I'm supposed to have also 3x. And because I add 3x to the numerator, I have to compensate this 3x by 3x in the denominator, because my last expression has to be equivalent to the previous one. So what I'm going to do next, I'm going to rewrite this one more time, but this time I'm going to combine these two fractions together. And what I'm going to write, I'm going to simply convert the limit of the product to the product of the limits. And I'm going to have limit with x approaching to 0 of sine of 7x over 7x times limit with x approaching to 0, and 7x times 1 is 7x, 1 times 3x is 3x, times limit x is approaching to 0 of cosine 3x times limit of x approaching to 0, and I'm going to apply the properties of the exponents. I'm going to flip this fraction and going to add the exponent -1, and I'm going to have sine 3x over 3x to power -1. So limit of x approaching to 0 of sine 7x over 7x is equal 1 times, in this fraction x and x will cancel out. I have limit of constant, so I'm going to have simply constant 7 over 3. Now limit of cosine 3x. If you are going to replace x by 0, you are going to have 0. Cosine of 0 is equal 1 times 1 times, now I have limit with x approaching to 0 of sine of 3x over 3x to the power -1. This is also equal 1. So I have 1 times 7/3 times 1 times 1 is equal 7/3. And this is the solution to my problem. We have another example on the board. Again, we are going to deal with fraction. Look at the denominator. If you are going to replace x by 0, you are going to have 0 in the denominator. We do not want to have zeros in the denominator. Now let's take a look in the numerator. We're supposed to find a way in order to eliminate this x, because we want to make sure that we are going to find the limit of this expression. So what we are going to do, in the numerator you have the square of the difference. We are going to apply this rule. Remember this rule? We have a minus b to the second power is equal a squared minus 2ab plus b squared. So I'm going to rewrite this as limit x is approaching to 0, and in the numerator I'm going to have x squared minus 2x sine x plus sine square x over x square. Next, please notice that we can divide numerator by the denominator. And I'm going to have limit x approaching to 0, and I have, let me write this step by step. I have x squared over x squared minus 2x sine x over x squared plus sine square x over x squared. Okay, because I divide the polynomial by the monomial. And what I'm going to have, I have limit x is approaching to 0. X squared divided by x squared is equal 1. Now this x and square will cancel out, and I'm going to have minus 2 sine x over x and I have plus, and I have sine square x over x squared. I want to get this form. So take a look what I'm going to do. I have sine x over x times sine x over x. So we can rewrite this one more time like this. I have limit of x approaching to 0 of 1 minus limit x approaching to 0 of 2 times limit x approaching to 0 of sine x over x plus I have limit x approaching to 0 of sine x over x times limit x approaching to 0 of sine x over x. Limit of constant is equal constant. So I have 1 minus limit of constant is 2 times limit of sine of x over x with x approaching 0 is 1 plus, again I have 1 times 1. 1 minus 2, 1 minus 2, because negative 2 times 1 is negative 2, 1 times 1 is 1, plus 1. 1 minus 2 is negative 1, plus 1 gives me 0. This is the solution to my problem.